Hey there and welcome. Today we are going to learn how to graph one-step inequalities. Let's get started. Alright, so the first thing that we're going to do is we're going to look at these words and we're going to match these vocabulary words to the symbol and then the dot that they use when graphing. So the first one that we have is greater than, and our symbol for greater than is this, nope, totally missed it, is this one down here. And the symbol for greater than is going to be an open circle. The next one we have is less than, which is that first one I actually went to. Goes the opposite direction of the greater than. And this one is also an open circle. These two open circles mean that the number that we have is not actually part of the answer set, but it's the closest answer we can get. And I'll show you what that means a little bit later. Alright, so our next one is equal. Hopefully, we all know an equal sign. And that one is going to give us a closed circle, which means that it is part of the answer set. Our next one is going to be greater than or equal to, and it's very similar to the greater than, but it has a line underneath it, making it or equal to, which is that closed circle. And all of these closed circles are exactly the same. And then our last one is less than or equal to, which is this very last option up here, just like that less than symbol, but with a line underneath it, giving that equality. And that one also gives us a closed circle. So that's those. Greater than, less than, greater than or equal to, less than or equal to, and then an equal sign. So for the first part of our lesson, let's talk about how many answers equations have. And equations just have one answer, right? And for example, that answer could be x equals 7. And that means that 7 is the only answer on the face of the planet that's going to work for whatever the equation is, right? That one singular number. But with inequalities, inequalities could be something like x is greater than 6. And if we have x is greater than 6, that means x can be any number on the face of the planet that is bigger than 6. Or x can be less than 6. And so that means that x can be any number on the face of the planet that is smaller than the number 6. And so when I said earlier that 6 is not part of that answer set, what I really mean is that we could have 5.9999999. Like these 9s are going to go on for absolutely ever. And every single time you add a 9, it's still a number smaller than 6. But we're just going to round up to that nearest whole number that we can just to make it a little bit easier to write. So this means that 6 is not actually part of the answer, but it's the closest thing that we can get to having just a nice, easy answer. But so there's an infinite number of answers that an inequality has, because 5 is less than 6, -3 is less than 6, -472 is less than 6, -5.99999 is less than 6. All of these numbers would fall in that answer selection. So there's an infinite number of answers that inequalities have, which is pretty cool. So let's start with a problem. And these problems are actually really similar to our one-step equations. The only difference really is the inequality, which does a little bit extra to it. So the first thing that we should figure out is our variable, which is the x. What's happening currently to our variable is subtraction, so the inverse that we need to do is addition. And very specifically, we're subtracting 7, so we need to use the inverse of adding 7 to both sides of that inequality symbol. So when we do this, I didn't do anything to my x, so it's just going to come straight down. -7 plus 7 gives me 0, so those two things eliminate. And then we have less than, we're going to bring that symbol straight down, and then 9 plus 7 is 16. So our solution says that x is less than 16. But as always, we need to check it. And so when we check it, the first thing I'm going to check is that 16 is actually my answer. So I'm going to rewrite my original problem. So x minus 7 is less than 9. I'm going to replace the answer that I got with my variable. I'm going to substitute. I'm going to say 16 minus 7 is less than 9. Now, if you remember from the previous video, I don't actually care what that number is on that side right now. I need to check to make sure that the math actually works, that 16 minus 7 gives me the correct number. I get that 16 minus 7 is 9, is less than 9. Now, 9 is not actually less than 9, but I got the same number on both sides, which tells me that that is the correct number. That gives me the closest to my boundary for the solution. But unfortunately, we're not actually done. Graphing inequalities has a couple extra steps to it, because we need to make sure that that actually should say that x is less than 16. So when I do my check, I'm going to check the number I get to make sure I get the same thing on both sides like we did here. And I'm also going to check a number smaller and a number bigger than the answer that we got. So something bigger and smaller than that 16. My number that's smaller, my favorite one to choose is 0. It makes everything a lot easier. So I'm going to say 0 minus 7 is less than 9. 0 minus 7 gives me negative 7. And now I have to ask myself, is negative 7 smaller than 9? And it in fact is, which tells me that my smaller is probably correct, right? X should be a number smaller than 16. But just to be sure, I'm still going to check a number bigger. Just to be safe, let's go with a nice even number of 20. So I'm going to plug 20 in for x. So I'm going to say 20 minus 7 is less than 9. 20 minus 7 is 13. I have to ask myself, is 13 less than 9? And it is not. So I know bigger is not the answer. So smaller. X has to be smaller than the 16 that we got originally. So I've checked 3 different numbers. I can say with all sorts of certainty that x is less than 16. So now we need to graph it. And this is really the new step here. So when I graph, I'm going to draw my number line. And the only number I personally care about having on my graph is that 16. Now, my less than symbol, if we remember all the way back up to here, less than, that blue line, was an open circle. So I'm going to draw myself an open circle here, which means that 16 is not part of the answers, but it's the closest thing I can get. And I need to shade where my numbers are going to be smaller than 16. And the numbers are smaller than 16 to the left. So here are my 2 answer solutions that I need. X is less than 16, and then the graph that shows that x is less than 16. That was kind of a lot. Hopefully it wasn't too confusing. Now let's do one more problem, and this time I have negative 8a is less than 24. So my variable is a. I'm currently multiplying, so my inverse is going to be divide. Now when I divide both sides of this inequality, I need to divide by what I'm multiplying by. I'm multiplying by negative 8, so the inverse of that is going to be to divide by negative 8. And whatever I do to one side of the inequality, I have to do to the other. So negative 8 divided by negative 8 gives me 1. So over here I'm left with a is less than. 24 divided by negative 8 is going to be negative 3. Now we got to check this. So when we check, I always start with the answer that I actually got. So negative 8a less than 24. So I'm going to plug in that negative 3. So negative 8 times negative 3. And negative 8 times negative 3 is positive 24 is less than 24. Now, again, 24 is not actually smaller than 24, but because I got the same number on both sides of that inequality symbol, that tells me that this number of negative 3 is good. Now I need to check to make sure that my solution is actually going the correct way. Because this right now is telling me that a has to be any number on the face of the planet smaller than negative 3. So let's check. Let's do our check for a number smaller. And I'm going to say negative 5, but you can choose negative 4, negative 10, whatever number you want, so long as it is smaller than negative 3. So negative 8 times negative 5 is less than 24. So I have negative 8 times negative 5, which is a positive 40. So I have to ask myself, is 40 smaller than 24? And it is not. 40 is not smaller than 24, which tells me that a can't be a number smaller. So that less than symbol is not correct. But let's check a number bigger just to be sure. And as I said earlier, one of my favorite numbers to choose is 0. So I'm going to choose 0. And in this case, 0 is bigger than 3. Negative 3. My apologies there. So I'm going to say negative 8 times 0 is less than 24. Negative 8 times 0 is 0, which is indeed less than 24. So because this gave me the true statement, I know that bigger is the correct way to go. A has to be a number bigger than negative 3. And you can choose any number bigger. We checked 0, but you can check negative 2, you can check 37. As long as the number is bigger than negative 3, you're going to have the correct answer. Now, this means that when we multiply or divide by a negative number, we need to take that inequality symbol and flip it the opposite direction. So let's graph this real quick. So again, the number that we care about is negative 3. It's an open circle. And this time we're shading where a is bigger, where the numbers are bigger than negative 3, which will be to the right. Now again, when we multiply or divide by a negative number, our inequality symbol is going to flip. And that's all we have today. So until next time, I'll see you later. Love you, bye.